Morning to everyone. My name is B. Ramu. I'm from 7th semester ECB section from Institute of Aeronautical Engineering College. So I'm going to give a presentation on this topic of a scalable and energy efficient MAC protocol for linear sensor networks. So this presentation explores the critical aspects of designing a MAC, or we can also call it as a media access control (MAC). This protocol specially for linear sensors networks, or LWSNS. Our focus will be on achieving optimal energy efficiency and scalability, two paramount considerations for the long-term viability and effectiveness of the specialized networks. We will delve into how these advanced MAC designs are pivotal for diverse applications, including the continuous monitoring of pipelines, roads, and bridges, as well as the rapidly expanding landscape of linear Internet of Things, or we can also call it as a IoT deployments. Let us discuss the introduction about this LWSNS. Um, the linear wireless sensor networks represent a distinct class of wireless sensor networks. It's totally based on the WSNS, wireless sensor networks, where this type of sensors nodes are deployed in a sequential or chain like arrangement, often spanning hundreds of meters to several kilometers. It's ranging from meters to several kilometers, whatever based on your application. Unlike a traditional WSNs with arbitrary topologies, we can see in olden days or traditional method there are a fixed type of arbitrary, so within that range only we have to set a sensors or like any type of arrangements. So it's uh, it's a well, coming to the linear wireless sensor networks. So in these networks there is no limit for the sensors nodes. uh, we can adjust into meters to several kilometers based on our application. So this type of linear wireless sensors are characterized by their uh, elongated and narrow deployment areas, which impose a unique communication constraints. One of the primary challenges in linear wireless sensors networks is the relay burden. The relay burden we can uh, explain as it's a data packet often need to traverse multiple hops along their linear chain to reach a base station, placing a significant communication load on a intermediate nodes, which is basically placing some amount of load to the intermediate nodes. So by doing this we can face a relay burden. So further, each node typically communicates with only one or two immediate neighbors, simplifying routing but increasing dependency on the reliability and energy status of the specific links. These networks are becoming increasingly critical for various applications, such as like large scale infrastructure monitoring, example oil and gas pipelines or railways tracks, border surveillance, and etc. Not only this, or some small cities IoT initiatives such as intelligent street lighting and traffic management system. So this type of smart systems also can face this relay burden. So there are different types of challenges in a MAC protocol design for linear wireless sensors networks. So the designing an effective MAC protocol for LWSN, this represents several intricate challenges, primarily stemming from their unique topological characters and operational environments. To overcome these hurdles is essential for ensuring that longevity, reliability, and responsiveness of LWSN deployments. So there are different types of challenges. Uh, we can categorize it into four. First one is energy constant, high latency, control overhead, and collision avoidance and packet delivery ratio. That is also called as a PDR. So let us discuss what is what in a brief introduction. So coming to the energy constants. So the energy constant nodes are in LWSNs are typically battery powered. It's working based on this battery powered, so often deployed in remote inaccessible locations, making battery replacement or recharging is very critical. So thus the energy efficiency is paramount in this type of MAC protocol. So the MAC protocol must minimize this their energy consumption for ideal listening, overhearing, collisions, and excessive retransmission to maximize network lifetime. It's all about there is a typical kind of what we can say, like rural areas or non-urban areas. So when we can go the type of places, so there is no type of facility to recharge or replacement of a battery. So in this type of situation we need to main focus on this energy constants. Next, coming to the high latency. So due to the multi-hop nature of linear topologies, which is a main characteristic of an MAC, so the data packets must travel sequentially from node to node. This is inherently leads to higher into in latency compared to denser latency. Mesh like mesh like networks, especially over long distances, you can know what is mesh. It's a basic thing. So the MAC protocol needs mechanism to expedite packet forwarding and reducing delay at each hop. And next, coming to the control overhead and collision avoidance. Efficient channel access is crucial, as well as the excessive control packets exchanges and add overhead and consumes energy. Simultaneously, the MAC protocol must effectively avoid the data collisions, which is leads to packet retransmission and wasted energy without introducing significant delays. And the PDR is also known as a packet delivery ratio. By maintaining a high packet delivery ratio, it's critical for reliable data collection, especially in monitoring application where data integrity is vital. The protocol must be robust against link failures, interference, and network cognition to ensure data reaches this sync reliable. So we can see the overview of existence MAC protocol approaches. In olden days, there are different types of MAC protocol. So in this flow chart, we can see the MAC is briefly divided into three protocols based on this access. So the first one is random access protocol, and a controlled access protocol, and a channelization protocol. So the first one is the access protocol. In this protocol also there are different types of protocols like ALOHA, CSMA by CD, CSMA by CA. So these are the different types of protocols in undergoes onto the random access. And coming to control access protocol, reservation, polling, token passing. And coming to channelization protocol, it's must needed for every type of approaches like a traffic system and a smart city kind of. So the channelization protocol is briefly divided into FDMA, TDMA, CDMA. So FDMA is known as a frequency division multiple access, and TDMA is a time division multiple access, and CDMA is a channel division multiple access. So while coming to the overview of existency, we can divide it into connection based, schedule, hybrid, reservation based, and token based. So these are the existing MAC protocol approaches, different types of approaches. So there are key concepts while designing a MAC protocol. There are different types of principle like scalable and energy efficient in MAC protocol of LWSNS. So to address the inherent challenges of LWSNS MAC protocol, design must adhere to specific principles that portrays both energy conservation as well as the scalability. So this principle guides to development of robust and long lasting LWNS deployments. So there are four types of key principles are there to while designing a LWSNS. The first one, adaptive duty cycling, coordinator sleep schedules, uh, collision avoidance mechanism, and dynamic queue management. So these are different types of principles. So for depth there is an explanation. So what is what? So much needed. Uh, so in this so sorry there is a limitations of existing MAC protocols. For that purpose we need to propose a new MAC protocol that is called as a line MAC, for example. So the line MAC, this building upon the principles of energy efficient and scalability for linear topologies. So we introduced line MAC, a novel MAC protocol especially engineered to address the unique demand of linear wireless sensors networks. So line MAC is a meticulously tailored from linear topologies where each node primarily communicates with its immediately upstream and downstream neighbors. This focus allows for highly optimized channels access and power management decisions that are not possible with general purpose MAC protocols. Finally, the protocol employs dynamic queue management at each node. These intelligent buffers handling priorities critical data packets, prevents cognition, induce drops, and minimize retransmission by reducing packet loss and ensuring timely deliver. LineMac enhances the overall packet delivery ratio, that is PDR ratio, and significantly reduces end-to-end delay, making it an ideal candidate for time-sensitive LWSNS applications. So we can see the bar, this graph, the evolution of simultaneously it results the PDR development or end-to-end delay or energy savings. So based on this graph we can say that it will evolution of the MAC protocol is day by day it will be increased while we are dealing with the line MAC. According that only we can tells. So we can see the energy savings is around 35 and end-to-end delay is the 30 and PDR improvement is the 17. So there is a comparison with other protocols. What we have that line MAC protocol. So a comparative analysis against established and widely used MAC protocol, highlighting a line MAC's distinct advantages in the context of LWSNS, while other protocols performing well in their intended environment, their inherent limitations become apparent when applied to long linear chains. There are key different differentiators of line map. So the key differentiators are energy efficiency, latency, scalability, and adaptability, and also burst transmission protocols, low power listening based protocols, specific linear chain communication, and DMAC. There are practical applications use cases we can use in pipeline monitoring, smart street lighting, bridge and tunnel structural health monitoring, environmental sensing along roads or railways. So these are the real-time applications where the MAC protocol can be used. So the conclusion is conclusion and future directions also. The development and implementation of scalable energy efficient MAC protocols are undeniable critical for the successful deployment and long-term availability of LWSNS. These specialized networks with the unique topologies constants demand tailored communication strategies to unlock their full potential. So there are future research avenues also is there. The avenues are machine learning integration, cross layer optimization, energy harvesting, and security enhancements. So these are the future research avenues based on their new innovation of different types of MAC protocol. So that's it. Thank you.